Alright, so what we're doing now is the last problem, number 30, the tax advice. Um, let's just go ahead and read this. Each year, people who have income file income tax reports with government. In some instances, people seek advice from accountants and financial advisors regarding their income tax situations. This advice is meant to lower the percentage of taxes paid to the government each year. I think advice is meant to lower the percentage of taxes paid each year is sort of the crux of the matter. Alright, so I'm going to stay focused on this. A random sample is obviously important, of people who filed tax reports resulted in the data in the table below. Does this data indicate that people should seek tax advice from an accountant or financial advisor? Test an appropriate hypothesis. Alright, so we're going to test an appropriate hypothesis and state your conclusion. This is set up as a table, okay? But I think trying to figure out what the table is telling us is the hard part of this problem. So we have two samples of people, alright? So of people who filed, right, there are two types. Had advice, right, and no advice, okay, where the had advice column that I'm really concerned about is right here, and the had no advice that I'm concerned about is this column over here. Now the trait that I'm really interested in is lower percentage of taxes paid, right? So I'm looking at paid, and really the trait is right here. Okay, this is the trait that we care about. Paid lower percentage of taxes. Alright. Now, of the people who filed, those that had advice, well, yes, had advice, that's these two columns added together. And so if you're in the had advice column, let me bring up the calculator. Basically, that's 19 plus 86 gives me a sample size of 105. So those that had advice is 105. So this is my P of advice. Is going to have 105 in the denominator. Okay? Actually, it's P hat because this is a sample. Alright, and then paid lower taxes is going to be the 48 plus the 24 is equal to 72. Alright, so here that had no advice is 72. So here I have my P hat of no advice is going to be equal to 72 in the denominator. Alright, so now the other thing that we're looking for is the trait that they paid a lower percentage of taxes. Well, if you paid a lower percentage of taxes, your yes is this row right here. And so these two values, the 24 and the 86, those are your successes. Okay? So you had 24 people with no advice, and then you had the 86 people with advice. Alright? So now we need to test an appropriate hypothesis. Alright, so step one, as always, is write our null hypothesis. And our null hypothesis in this particular case is going to be that the P of A, right, the people that had advice, minus the people with no advice is going to be equal to 0. That there was no difference. Okay? The alternative hypothesis to that is that the people with advice minus the people who had no advice is going to be greater than 0. And some of you are going, why is that? when this says lower percentage of taxes paid? Well, what you want is more people that had a lower percentage of taxes paid. So if you had advice, right, and that lowered your taxes, this percentage should be higher than this percentage, and that gives you your greater than, okay? So don't be fooled by the lower percentage of taxes. The lower percentage of taxes is the trait, okay? What we're testing to see is, should people seek the advice from an accountant or financial advisor? And so the way we've set this up is that the advice should be more than the people with no advice, and so that would give us a hypothesis test of greater than 0. Okay? So again, this was the tricky part. The tricky part was coming up with your p-hats and this direction of this inequality, because it is a little bit confusing, but hopefully I have erased all confusion and now you're just super happy. Maybe that's not a happy face, this is. Okay, so now you're just super happy. Okay? Now, the second step is to check your assumptions. Now, the first assumption is always to check random and independent, and the random sample of people is right here. Alright, so that's good. Okay, and then we need to check and see if it's less than 10% of the population. And if you have 105 and 72, that's approximately 200 people. That would be 2,000 tax filers. There are more than 200 people who filed taxes, so that's good. And then last but certainly not least is our sample size. And then of course, basically you want successes to be greater than 10. Alright? And in both cases, the successes are 24 and 86. Those people paid less in taxes. Alright? Now, you want the failures to also be greater than 10%. Alright? Well, that's your 72 minus your 24 and your 105 minus 86. And amazingly enough, that ends up being 48 and 19, right? So this is going to be 48 and this is going to be 19. Now some of you are like, hey, wait a minute, why are you doing it that? Usually it's n times p, right? And n times 1 minus p. Except I don't know what p is, I only have p hat, alright? And so, of course, you can go ahead and calculate what each of those p hats are. So let's go ahead and do that, where you can see it, alright? And so 24 divided by 72, 24 divided by 72 gives you a p hat of 0.333, and 86 divided by 105 gives you a success rate of 0.82. So you have 0.33 and 0.82. So you do have to check it twice, right? So you have 72 times 0.33, right? And you have 105 times 0.82. And I'm going to scroll this over just a little bit so we can see the edge here, alright? And 72 times 0.33, 72 times 0.33 is, oh my gosh, it's 24, okay? Which is what we got up here, okay? Because this is the number of successes, this is the number of successes, this is the number of failures, and this is the number of failures. If you take 105 times 105 times 0.82, you get 86, alright, which is that number right there. Alright, so you've got the 24 and the 82, and of course, if you go ahead and you take 72 times 1 minus 0.33 and you do that in your calculator, you do get 48, and if you take 105 times 1 minus 0.82 and you do that in your calculator, you do get 19. And you can check that for yourself, but so the successes and the failures are met. And that really makes us happy. Right? The sun is shining. Okay? Now, after that, what we want to do for step number 3 is we want to draw the picture and calculate. Oh, draw from a picture. I'm sorry this doesn't look better, but it's really hard with the stylus. Alright. Now remember, what always goes in the center is your null hypothesis. And your null hypothesis here is 0. And now I need to do my standard deviations and mark my actual test statistic. Okay? So let's calculate our standard deviations, our standard error. Remember, the standard error formula is going to be equal to the square root, right, of p times 1 minus p all over n. But now remember, we've got one sample and we have a second sample. So you actually end up putting both of them together underneath the radical like this. Now it turns out that it's actually best to go ahead and do this all at once in your calculator. And so my first p hat is going to be 0.33. And then 1 minus 0.33 all over my 72, right? There's my 72 for my n, plus, right, 0.82 times 1 minus 0.82 all over here, it's 105. Alright, sample size right here, 105. So let's go ahead and put that in La Calculator. So again, square root 0.33, right? 1 minus 0.33, close, divide by 72, plus, alright, now you're going to have 0.82 times 1 minus 0.82 divided by 105. And now the division's multiplication is going to come first, the addition is going to come in the middle, and then it'll take the square root, and so you're going to get 0.067, which is basically about 6.5%. 0.067. Alright, so that's our standard error. So now I'm going to have plus 0.067 here and negative 0.067 over here. And then I need twice that much, 2 times 0.067, for two standard deviations, 13.4. Right, so here's my 0.134, negative 0.134. Okay, so now I need to put my test statistic on here. I actually need to take my p hat of advice minus my p hat of no advice, and my p hat of advice was 0.82, my p hat of no advice is 0.33, and so my actual test statistic is going to be 0.82 minus 0.33, and I get 0.49. 0.49. Now if this is 13, like 0.49 is like way over here, and so if I wanted to fill this in, right, with greater than, I'm going to go this way, because remember it's greater than 0, so I'm going to go this direction in the tail, and I'm way over here at 0.49. How far over is it? Well, now I need to figure out my z-score, right? So my z-score is going to be equal to, right, my 0.49 minus 0, the value that I got, minus the center of my distribution, divided by 0.067, my standard error number that comes from right here. If you do that in your calculator, right, so 0.49 minus 0, make sure you put it in parentheses, divided by 0.067, you end up with 7.3. Now, as of this point, right, 7.3, this is 7, almost 7.5 standard deviations away from the center. This is seriously unusual. You can see how far over it is. This is unusual. So we're definitely going to fail to reject. But let's go ahead and calculate the p-value. Right, so p-value, this is the normal distribution, so we are going to use the normal CDF, and my leftmost value is the 7.3, my rightmost value as I go this way, eventually 100 is small enough. And it's the normal CDF, so I don't need any degrees of freedom, so I'm going to plug that in. So here's my normal distribution. So my normal CDF is number 2, and so I'm going to put in 7.3, 100, and then of course 0, 1, paste, enter. Gives you 1.45 times 10 to the negative 13. Okay, so please don't put 1.3, okay, because it's 1.3 times 10 to the negative 14, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It's this number right here. This is basically a great big 0, okay, which is what we would expect with a value that is this many standard errors away from the center, okay. So that leads us to number 4. Step number 4, state the conclusion. And so basically we reject that the difference in proportions of people who file and pay lower taxes with advice and with no advice is 0. Okay? We're rejecting that the difference between people who file and pay or lower taxes with advice and with no advice is 0. And that's because we have strong evidence that the difference, right, blah 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 blah, in proportion is greater than 0. Okay, and you always want to state the p-value and write out p-value. What is the p-value? The p-value is basically 0, and that makes us happy. This was a little less comprehensive, okay, as far as writing out the steps and stuff. I didn't write out the null. I didn't write out the null and the alternative hypothesis, but they are written out here, okay. So you do have that. I did do all of the calculations, but I think where I focused was the setting up of the problem. And if you think about it, with this particular table of data, the setting up of this problem and getting your null and your alternative hypothesis and your test statistic, these were the really important parts of the problem. Alright, so again, thank you for watching this video, and have fun with math. Until next time.